Before we start this WEM seminar series, so can you please follow the instruction in the chat box to key in your name, your affiliation, and also student ID number for attendance. Mr. Royal, can you hear me?
Yes.
Okay, Mr. Royal, can you make the presenters, Mr. Sanjeev and Kupiano's co-host as well, so that they can share screen?
Okay.
Yeah. Okay. So please be noted that today's seminar, as others as well, will be streamed live on Facebook, which is already on Facebook Live now. So please do share on your social media platforms so that these meaningful activities can reach out to a large audience amongst your professional networks. So before we start today's agenda, I would take permission to introduce our presenters today. So let me share the information first to everyone to give a little bit of background. Sorry, there is some technical issue, so I was just forced to leave. Okay, so let me share the screen and introduce today's presenters. Great, so everyone is looking at my screen, right? So for today's presenters, the first presenter would be Mr. Sanjeev Nupen. So Mr. Sanjeev is a very, everyone knows Sanjeev. He's been very active in our seminar, and he's been with us for several years, starting from master. So coming to today's, finally Sanjeev has the chance to share his work. So thank you, Mr. Sanjeev. So coming to today's seminar series, Mr. Sanjeev will be sharing with us his presentation on evaluation of the 𝐂𝐸𝐷𝑒X regional climate models, RCMs, for simulating climate extremes in the Asian cities. Mr. Sanjeev, core area of interest includes hydrological modeling, groundwater modeling, climate change, land use analysis, and GIS remote sensing-based studies. So Mr. Sanjeev will start today's seminar series. So after Mr. Sanjeev, our second presenter is Ms. Pianuch. So Ms. Pianuch is also a PhD student of Water Engineering and Management program. Her research interests include climate change impact assessment, flood risk management, and hydrodynamic modeling. So coming to today's seminar, Kun Pianuch will be sharing her research with us, focusing on detecting climate variability and hydrologic alteration in the Pasak River basin of Thailand. So with that, I would like to stop my share now, and then may I invite Mr. Sanjeev Nupen to start sharing your screen, and so that we can start today's seminar series. Thank you.
Thank you, Dr. Locke. Everyone can see my screen?
Yes, we can see your screen now. Yes. Thank you, Sanjeev. You may start.
Thank you so much. Very good morning to everyone. Welcome all of you to the WEM Seminar Series 10. My name is Sanjeev Nupen, and I'm currently a PhD candidate in Water Engineering and Management program at the Asian Institute of Technology, Thailand. Today, I am presenting my research on title Evaluation of 𝐂𝐸𝐷𝑒X Regional Climate Models, RCMs, for simulating climate extreme in the Asian cities. This study was conducted under the project Mapping Groundwater Resilience to Climate Change and Human Development in Asian Cities, funded by the Asia Pacific Networks for Global Change Research, APN. So in today's presentation, I'll be covering introduction, materials and methods, result and discussion, conclusion, and appendix part. So let me begin with the background. The world climate is changing at full tilt in recent years, and climate change has become a serious threat to water resources by impacting through change on major long-term climate variables such as air temperature, precipitation, and evapotranspiration. Climate models are widely relied upon to investigate the response of climate system to various forcing, for making climate prediction on seasonal to decadal time scale, and for making projection of future climate over coming century and beyond. So basically, there are two climate models, which are global climate models GCMs and regional climate model RCMs. So global climate model GCMs are the numerical models representing the physical process in atmospheres, ocean, cryosphere, and land surface, and can simulate the response of global climate system to increasing greenhouse gas concentration. And RCMs are the high resolution nested regional climate modeling technique, and it uses initial condition, time dependent lateral meteorological condition, and surface boundary condition derived from GCMs. So usually GCMs are of coarser resolutions, and RCMs typically include greater detail, that is better refined topography features and more complex physics calculation. So moving on to statement of the problems. So although there are large number of RCMs available in the Codex archive, the issue of the reliability for a specific region must still be confronted. And the inherent uncertainties, along with other factors such as time limitation, human resource availability, or computational constraint, make it imperative to sort out the most appropriate set of RCMs for assessment of climate change impact in the region, and hence the evaluation of climate model is much needed prior to their use in impact assessment study. So moving on to objectives of the study, the main objective of the study is to evaluate the regional climate model RCMs for simulating climate extreme in Asian cities, and the specific objectives are to evaluate the skill of climate model in simulating the past climate using the performance indicators, and to reveal the weightage of each performance indicator using entropy methods, and to select the best performing regional climate model based on the ranking techniques. Moving on to the study area consists of three fast-growing Asian cities, which are Bangkok and its vicinity in Thailand, Ho Chi Minh City in Vietnam, and Kathmandu Valley in Nepal. Bangkok and its vicinity is the largest city among three cities with area of 10,300 square kilometer and population of 11.3 million as per the census of 2010. Bangkok and its vicinity and Ho Chi Minh City is situated in tropical region, whereas Kathmandu Valley is situated in subtropical and temperate region. This table shows the data required for the evaluation study with their respective source in all three Asian cities. And this table shows the list of 21 RCMs with their driving model and driving model institutes used in the evaluation study. So in the upcoming slides, I will be using model serial M1, M2, and so on, rather than using the whole RCM name. So moving on to the overall methodology. So this figure shows the overall methodological frameworks for the evaluation of RCMs in the Asian cities. So in this study, 21 regional climate models with the gridded resolution of 0.44 degree times 0.44 degree from the Codex data portal was compared with the observed climate data sets based on 6 climate indices, which are conjugative dry day, simple daily intensity index, number of extremely heavy precipitation days, maximum one-day precipitation amount, mean of maximum temperature, and mean of minimum temperature. The performance of this comparison were assessed using 4 performance indicators, which are the correlation coefficient, normalized root mean square deviation (NRMSD), absolute normalized root mean square deviation (ANRMSD), and average absolute relative deviation (AARD). The entropy method was used to reveal the weightage of each performance indicator, and finally, the ranking techniques called weighted average technique was used to rank the RCMs. So this table shows the description of climate indices used in the study. And the selection of these climate indices were based on similar kind of the study done by Zhang et al. In 2011 and Southeast Asia Regional Climate Downscaling Project, (CICLID). So moving on to performance indicator, the correlation coefficient provide the information on the strength of the relationship between observed and simulated value, and the value of the correlation coefficient ranges from -1 to +1. The normalized root mean square deviation is the measure of difference between the observed value and model projected value, and a smaller value of NRMSD indicates better model performance. Likewise, absolute normalized root mean square deviation is the ratio of mean of difference between simulated and observed value to the mean of observed value, and average absolute relative deviation AARD is the average of absolute value of the relative error. And again, the smaller value of ANRMSD and AARD indicate better model performance, and a value of 0 is preferred. Now moving on to entropy method. The entropy method was used to calculate the weightage of each performance indicator, and this method consists of 4 steps. The first step is formation of decision matrix between the performance indicator and RCMs. The second step is the normalization of decision matrix. Here, 2 equations were used for the normalization. For the correlation coefficient, higher value indicates the better performance of the model. Therefore, the maximization type of normalization was used. And for other 3 performance indicators, smaller value indicates the better model performance. Therefore, minimization type of normalization was used. The third step of entropy method is the determination of entropy value for each performance indicator, and finally the entropy weight of each performance indicator based on degree of diversification. Now moving on to ranking techniques, the weighted average technique was applied to rank the RCMs in Asian cities, and this technique depends on the weightage of the performance indicator. Now moving on to result and discussion section, the ranking of 21 RCMs was done for all 6 climate indices and 3 Asian cities, but because of the time being in today's presentation, I will only be presenting the ranking of 21 RCMs for consecutive dry days, and for other 5 climate indices, I have put the result part in the appendix section. So this table shows the rectangular matrix of performance indicator obtained for 21 chosen RCM for consecutive dry day in 3 Asian cities. So this is the first step of the entropy method, that is formation of decision matrix between RCMs and performance indicator. So here the green color indicates the good model performance and blue color indicates the bad model performance. So for Bangkok and its vicinity, RCMs M11 is correlated well with the observed data with the value of 0.206, whereas RCM M19 has the least correlation. Likewise, RCM M11 is the most preferred RCM in case of NRMSD and ANRMSD, whereas RCM M3 is the least preferred RCM in case of NRMSD and ANRMSD. And for AARD, M8 and M3 are the most and least preferred RCMs respectively. So this table shows the rectangular matrix of normalized performance indicator for 21 chosen RCMs for consecutive dry day, the weightage and rank in 3 Asian cities. So the second step of the entropy method was to normalize the decision matrix. So in case of correlation coefficient, the maximization type of normalization was used, whereas for other 3 performance indicators, minimization type of normalization was used. So after the normalization of the decision matrix, the entropy value 𝐂𝐸 was calculated for all 4 performance indicator, and finally the weightage of all 4 performance indicator was calculated. So for Ho Chi Minh City, the correlation coefficient has the higher weightage value of 43.5%. Likewise, for NRMSD, the NRMSD has 16.3% weightage, and ANRMSD and AARD have 24.7 and 15.6% weightage respectively. So after calculation of weightage of each performance indicator, the weighted average value of each RCM were calculated using weighted average techniques, and those RCMs which has the highest weighted average value occupies the first rank. So for example, in Kathmandu Valley, RCM M11 has the highest weighted average value of 0.875, and hence it occupies the first rank. So this spider plot shows the weighted average value of all the RCMs and climate indices for Bangkok and its vicinity, Thailand. So for consecutive dry days, RCM M11 has the highest weighted average value. Likewise, for simple daily intensity index, M6 has the highest weighted average value. For R50mm, RCM M11 has the highest weighted value, and so on. Likewise, for Ho Chi Minh City, RCM M9 has the highest weighted average value for consecutive dry day, and RCM M11 has the highest weighted average value for consecutive dry day in Kathmandu Valley, Nepal. So moving on to final selection of the RCMs. So this table shows the rank of 21 RCMs for all 6 climate indices in 3 Asian cities and their rank sum. So here, after calculating the rank of all the RCMs and for all 6 climate indices, the rank were summed to obtain the final rank sum. So, and the RCM with the least value of the rank sum is the better performing RCM. So for example, in Bangkok and its vicinity, for RCM M11 has the least rank sum, that is 24, and hence RCM M11 is the better performing RCMs in Bangkok and its vicinity, Thailand. So moving on to conclusion, first let me describe a comparison of selected RCMs in Asian cities. So these are the top 5 RCMs in the respective Asian cities, and the RCM was 44 SMHI RCA4 IPSL CM5AMR and was 44 SMHI RCA4 CCCMA CANESM2, occupies the top 5 rank in all 3 Asian cities. Moving on to conclusion, each indicator responds differently for various RCMs and climate indices, and the best model for one climate indices is not the same best model for other climate indices. RCMs M11, M14, M7, M10, and M13 are top 5 better performing RCMs in Bangkok and its vicinity, Thailand. RCM M12, M7, M6, M11, and M13 are the top 5 better performing RCM in Ho Chi Minh City, Vietnam, and RCM M3, M12, M11, M7, and M6 are the better performing RCMs in Kathmandu Valley, Nepal. So this work has already been published in the Science of Total Environment Impact Factor 7.963, and you can access to this journal using this link. So with this, I'd like to end my presentation. Thank you so much for your attention. If you have any question, I'll be happy to address it. Thank you so much.
Yes, thank you, Mr. Sanjeev, for a very comprehensive discussion and presentation. I think this is although we have listened to a number of climate change and vulnerability impacts, but I think this is one of the most comprehensive, and I really like the way that you presented on the results. So with that, I would like to open the floor for questions and comments. Please, everyone, if you have any questions for Mr. Sanjeev, please unmute yourself and ask questions. Thank you. Yes, Sonu, I saw that you have unmuted. Please ask questions, Mr. Sanjeev. Thank you.
Hello, good morning, everyone. First of all, I would like to say thank you a lot to the Dr. Sanjeev sir, and it's really comprehensive presentation. And I would like to ask yes. Hello, can you hear me, sir?
Yes, I can hear you.
Yeah, sir, I would like to ask you the what's the importance of giving the different weightage for the all indicators? Why not the all equal indicate? Like if you can provide the equal weightage to the all indicators, what will like our result will affect or not? So
Yeah, thank you, Sonu, for the questions. So yeah, that's really a good questions. And actually, that question I also faced while publishing the paper also. So yeah, definitely, if you provide equal weightage to all the indicators, the result will be affected. So actually, in this work, I use the entropy method. I use this entropy method to provide the weightage to all the performance indicators like based on the literatures. So actually, while defining my methodology, I use the entropy method, and hence I provide the weightage to all the performance indicator using that entropy method.
So, sir, suppose some of the researcher wanted to use the any of the models. So, what will be accuracy and uncertainty? Like, if some people are using the equal weightage method and the different weightage method using the compromise programming, no, using the entropy method. So, what like accuracy? Like, you can say that this method is okay or equal weightage is okay. Do you have any comment on such things?
Actually, like if we use, I have also done analysis providing equal weightage to the RCM, sorry, performance indicator also, but this that affect my results. The top 5 ranking RCMs might be different in that case, but in my work, I use the entropy method based on several literature review. So, so I think like the accuracy, as depending on the literatures, I can say that using the entropy method, the accuracy will be good.
Yeah. Okay. Thank you very much, sir. Yeah.
You are welcome.
Yes, we still have time for one more question. Anyone have question or comments to Mr. Sanjeev? Please unmute yourself. Thank you. Okay, so it is not before we move on to before we move on to the second presenter, then I would like to make some announcement, especially to the new doctoral students. So please be, use this platform, WEM Seminar Series platform, to showcase your research. I know that you are new and then you have not even started your research yet, but you can please use this one to showcase your previous work, your research background. Either is in like your, some of you are already lecturers in the university, so you can use this platform to showcase your previous works or your previous publications, so that we can create a more inclusive and more engaging research environment. That's what we have been building for our water engineering program. So I already had the orientation to some of you, so please be, look ahead to be a presenter in this WEM seminar series in the future. So before we continue to the second presentation, may I request everyone to turn on your video so that our photographer over here, Mr. Roel, will arrange the group photo for everyone. Thank you. So Sanjeev, may I request you to unshare so that we can have a group photo. Thank you, Sanjeev.
Okay, so hello to everyone. Please turn on your video. And then we have the fourth screen, two screen. So if I count 3, please smile. For the first screen, so 1, 2, 3. Okay, for the second screen, smile, 1, 2, 3. Sorry, hold on. Okay, smile. Okay, thank you very much.
Thank you, Mr. Rao, for being a very reliable photographer as always. So with that, may I invite Kun Pianut to start to share your screen so that we can continue our WEM seminar series. Thank you, Mr. Pianut.
Thank you, Dr. Locke. Can you hear me? Hello? Hello?
Yes, we can hear you.
Yes.
We can hear you. Yes.
Good morning, everyone. My name is 𝐵𝐴នុត 𝐵𝐴 PhD student in water engineering and management. Today, I'm going to present my special study on the topic of detecting climate variability and hydrologic alterations in the Passak River Basin, Thailand. My presentations will cover the 6 parts. I will start with the background of the study, objective of this study area, methodology that I use, results and discussions, and finally conclusions. Let's start by going to some aspects that why this study is needed. The climate change is growing concern with the rising global temperatures. IPCC reported temperature in the Southeast Asia are expected to increase by 1 to 2 degrees Celsius in the next 50 years. Increasing temperature will accelerate water evaporation rate and therefore drive change in the rainfall pattern and water runoff. From what they say, the implications were that change in climate are interlinked with change in the hydrological cycles. That is the most important feedback cycle in the climate system. These phenomena are likely to induce more frequent flood and drought or extreme events that's already affecting people, ecosystem, and livelihoods. Although climate change occurs on the global scale, its impact often vary from regions to region. So assessing also change in the climate variables and streamfall alteration is an inevitable precondition to find out appropriate adaptations and mitigation measures. In the case of my study area is Passak River Basin, which is one tributary of the 𝐶𝐻 River Basin. The topography of this basin is an elongated basin that has the main river flow to the center of the basin, and it has a short tributary. So when the heavy rainfall occurred, there was no storage to retard the flow cannot drain quickly from the upstream to the downstream. It's causing a severe flooding in this basin. The Passak River Basin has been affected by flood nearly every year. As you can see in this graph is a flood inundated area from 2005 to 2019, 15 years. 30 years is flood occur in this area. So flooding is seem to be a permanent threat to community livelihoods and the household economic, given the highly and subsistent agriculture. That's why this river basin is vulnerable to climate change. So this study aims to investigate change in the hydrometeorological variables related to the magnitude and frequency of flood in the Passak River Basin. To achieve this objective, I will analyze long-term trend in the historical rainfall, as well as maximum and minimum temperatures, and also evaluate historical hydrologic alterations on the Passak River. This is the briefly information about the study area Passak River Basin again. The Passak River Basin is located in the northern and the central regions of Thailand. This is a tributary of Chao Phraya River Basin, which has a catchment area around 15,616 square kilometers. The Basalt River is the main river in this basin. The climate conditions in this basin can be divided into two seasons, wet season and dry season. The wet season starts from May to October, and the dry season starts from November to April. An average annual rainfall is around 1,200 millimeters per year. 80% rainfall is in the wet season. For average annual temperature vary from 26 to 28 degrees Celsius. This river basin has a big reservoir, has a big multi-purpose reservoir, which is located in the downstream of this basin here. Its name Basalt Jurassic. It has a storage capacity around 930 million cubic meters. This dam is operated to serve the water for irrigations and flood control and generate hydroelectric power. This dam was constructed on the Basalt River in the year 1994 and start operation in the year 1999. Let's move on to overall methodology framework. I start with separately analysis climate and stream flow. I use man and candle test and sense slope estimator for detecting trend and rate of change in the climate variables, including rainfall, maximum and minimum temperatures. And at the same time, I try to evaluate the hydrologic alterations on the Basalt River at the available gauging stations by using the indicators of hydrologic alterations, or called shortly IHA software. This is the data that I use for the analysis. There is two groups of data that I use: meteorological data and hydrological data. For meteorological data, it consists of three variables: maximum and minimum temperatures and rainfalls on monthly basis. For hydrological data, I use only daily discharge from these two stations to be an input for IHA software. From the overall methodology frameworks, I would like to go into detail over the climate analysis. Climate analysis using man and candle test and sense slope estimator. The trend of observed rainfall and maximum and minimum temperatures were calculated by using the non-parametric man and candle test. It has been widely used and recommended by the WMO for detecting trend of meteorological and hydrological data because it doesn't consider any distributions of the variables, and some variables have a non-Gaussian distribution. So in this statistic case, the null hypothesis is defined as there is no trend, and the alternative hypothesis is defined as a trend increasing or decreasing in the time series data. I set this statistic level for rejecting null hypothesis. To estimate the true slope of existing trend or change per year, I use the set slope estimators because it's robust to estimate the trend. The results of man and candle test can be a positive and negative value. Positive means the increasing trend, and the negative means decreasing trends. In this study, I analyzed trend and rates of change to see the annual and seasonal variable of these variations of these variables. This is the results of annual and seasonal rainfall trend analysis. The results in each station is shown in this spatial distribution map for the annual rainfall in the wet season, and rainfall in the dry seasons. And I also summarize exact value in these tables. You can see in this map, the upward triangle indicates the increasing trend, and the downward triangle indicates the decreasing trend. And the significant change is indicated by the few triangles. You can see in this map, rainfall in annual rainfall and rainfall in wet season has the same pattern. There is no significant increasing trend almost across this basin, except for the upstream stations here, which has a insignificant decreasing trend. For the dry seasons, the rainfall in the dry season vary in each station. Only the trend of rainfall at the Phetchabun station has a increasing significant with a change rate 1.5 millimeter per year. This is the annual and seasonal maximum temperature trend analysis. You can see that all annual and seasonal trend are the same pattern, which increasing trend at the different significant levels, except for the Pak Chong station, which had the increasing insignificant, non-significant. The magnitudes of change in annual maximum temperatures and the temperature in the wet season were increasing 0.23 degrees Celsius per decade, while in the dry seasons, the temperatures is increased around 0.18 degrees Celsius per decade on average. This is the annual and seasonal minimum temperature trend analysis. You can see that this is a highly and very highly significant increasing trend of the all annual and seasonal minimum temperatures were detected at the all station with the length from 0.3 to 0.5 degrees Celsius per decade. If we compare the magnitudes of change between the maximum and minimum temperatures, we can see that in this graph, the orange bar is the rate of change of minimum temperatures, and the red bar is the maximum temperatures. I found that the minimum temperature increasing at a faster rate than the maximum temperatures because of a decrease in the diurnal temperature lengths. And some researchers said that decrease of the diurnal temperature length is the evidence of climate change. That is, let's move on to the evaluations of hydrologic alterations on the Basalt River. The observed there is info data at the STT station, which located in the upstream and the downstream at the S9 station, and the S9 stations, which located at the downstream behind the Basalt Dam, were used in this analysis to see the impact of climate difference and dam operations. For this analysis, I define the P impact and the post impact. We have to define the periods of P impact and post impact to see the hydrologic alterations. For the P impact, is starting from 1998 to 2009, and the post impact start from 2010 to 2019. For the downstream stations, the pre-impact is the period before the dam construction, and the post-impact is the period after the dam operations. The period is defined to compute the degree of hydrologic alteration at each station by using IHA methods of the IHA software. This software is developed by the Nature Conservancy. As I told you earlier, I use the IHA method to analyze hydrologic alterations. The IHA method is based on a set of 33 indicators classified into 5 fundamental characteristics of hydrologic regime, which including these five group magnitudes of monthly water conditions, durations, and annual extreme water conditions, timing of annual extreme water conditions, frequency of occurrence, and rate of change in the water conditions. And this is the IHA parameter in each group. This parameter will facilitate the hydrologic analysis in the ecologically meaningful manners like this. For example, the annual maxima can be influenced on the structuring of river channel morphology and physical habitat conditions, and the timing of annual extreme water conditions can determine the rice cycles requirement and spawning pool for migratory fish. Okay, let's move on to the results of streamflow alterations. This is the results for STT stations or upstream station, and this is the result of the S9 station or downstream stations. The alteration are expressed in terms of deviations percentage here. This is the result of the group 1 magnitudes of monthly median flow. You can see that for STT station or upstream stations, there is no change in the shape of hydrograph, but the magnitude in peak is decreasing. For the S9 station, the rising land lag from August to September, and the fall during dry season here is dramatically increased around 500%. Let's move on to the group 2, the result of group 2. This is the magnitudes of annual extreme water conditions. You can see that the minimum flow of the station, upstream station, decreased about 20%, and the maximum flow increase around 70%. Is likely to increase in extreme event. For the S9 stations, which is located behind the Basalt dam, the minimum flow is increasing around 170% relative to the pre-impact, and the maximum flow decrease around 15% relative the pre-impact period because of the dam operation. This is the results of group T to group 5. Timing of the group T is the timing of annual extreme water conditions, and the group 4 is the frequency and durations of the high and low flow pulse. For the group 5 is the rate of water conditions change. For the S3T station or upstream stations, the period of peak, the periods of the annual maximum is delayed for 1 month from August to September. The streamflow seems to be gradual change in terms of magnitudes in contrast in the extreme condition. For the S9 station, For the S9 stations, the annual minimum is delay from the dry seasons to the wet seasons from April to June. For the annual maximum time, the timing of annual maximum is seem to be come faster for 1 month. For the frequency and durations of high and low pulse, for this station, it seems to be the more frequent in high pulse and less in low pulse. For the fall rate and number of reversals increase around 60% relative to the pre-impact periods. It may be because of byproduct of hydropower generations. In the conclusions, the annual and seasonal minimum and maximum temperature indicate significant increasing trend, while the rainfall pattern detected insignificant increasing trend, except for the upstream stations, which for the rainfall alterations on the Basalt River, the median monthly fall at the upstream station tend to decrease, correlate with the rainfall trend in the upstream stations. For the downstream stations, the pattern of median monthly fall hydrograph at these stations was altered by lacking of the rising lump from August to September, drop in peak, and increase during the dry seasons with the less 28 cubic meter per second because of the dam operation. So this study clearly captures significant change in the key climate variables, implying climate change and human-induced rainfall alterations in the Basalt River basin. This study would be the beginning of these perceptions and awareness for identifying risk management intervention in the future. Thank you for your attention and interest.
Thank you, 𝐶𝐿 for your presentation. Actually, I have attended your special study and later on the proposal, and then I can see that's the real evolution from last time. And then, more and more, you have taken the comments of, on the committee and then built a very comprehensive and a much better version of the research. So for that, I really, give my best compliments to you as well. So with that, I will open the floors for 1 to 2 questions for 𝐶𝐿 in her study. Thank you, everyone. So the audience, if you have questions, please unmute yourself and ask questions directly to 𝐶𝐿. Thank you. Actually, one of my advisees, Ms. Tadam, is also working closely in this area. So may I invite Tadam? So you have any questions or even, like trying to clarify about this area, because that will be very useful for your research. May I invite Tadam? Ms. Tadam?
Good morning, sir. Thank you so much.
Yeah.
Thank you for continuous presentation. I think I have no question today, and the presentation is very comprehensive and plenty of information for me, especially about the area. Thank you so much.
Yeah, thanks, Ms. Tadam. So anyone have questions? Yeah, thank you, Tadam. Have any questions? Please unmute yourself and ask questions. Thank you.
Hello.
So, yes, Sanu. Yes, thank you.
Thank you very much, Pinot. You have a very good presentation. Like I can also understand most of the doubt I have also cleared from your presentation slides. And I have still one doubt on your presentation. Can you please go to the presentation slide number 12?
Yeah.
Yeah, so here you can see main candle. You have analyzed the trend of the using the main candle as well as Sense-Love method, and Sense-Love was used to find the trend per year, right? Increase or decrease per year. So here negative sign is indicating the decreasing trend, right?
Again, please.
Negative sign
Yeah.
is indicating the decreasing trend, and positive sign is indicating the increasing trend, right?
Yeah. Yeah.
So in Mann-Kendall test, we have a two value, negative as well as the magnitude. So what this magnitude indicates?
Magnitudes of change.
Yeah, magnitude of the change. So what's the difference between Mann-Kendall and Change-Slope method?
Mann-Kendall is, I think, in my opinion, Mann-Kendall used to define only the directions.
Yeah.
Yeah.
So direction we can directly tell based on the negative and positive sign, but I am just worried about this magnitude. So it have two things like negative as well as magnitude, so it might have some meaning, and I am still not clear on that. I think
sorry.
we can discuss later also, like if you have any information on that, you can please share with me that.
Okay, thank
you
you for
very
your
much.
question.
Thank you, Sanu, for your comments. Actually, I have also the questions in this slide, and later on when you do the results of the IHA, because I can see that you pretty much analyze the annual and seasonal rainfall trend analysis. So have you tried to look at if there are any correlations between these two results?
Yes, I try to analyze correlations at the upstream stations with the rainfall trend with the streamfall alterations at the upstream station also. I found that it has a correlate around 0.4 or 0.5. Okay.
Okay. Yeah. And how about the downstream?
I think the downstream has a substantial effect of the Basalt dam, because the station that I use is located behind this dam.
Okay. So the upstream, because it's more or less pristine without anthropogenic factors.
Yeah.
So the correlations between the raw data analysis and the IHA is higher, whereas in the downstream, with the dams, then it's more controlled, so the correlation is lower, right? I think this is a very interesting finding. So I think that can be in your discussions, because either you do trend analysis using Mann-Kendall's manually, or you use IHA. It's pretty much tell the same story. But if you can link that with the correlations and compare the reasons, I think that will be very useful for researchers. That if your basins have pristine, then the difference between those two will not be that significant. But if there are some alterations, anthropogenic alterations, let's say if there are reservoirs, if there are dams, then I think you will have to be a little bit more careful of what methods to use to account for the anthropogenic changes. Yeah.
Thank you for your comment.
So okay, we still have time to accommodate questions. Any other questions for Kunpiyanut?
Yeah, I can please. Hello.
Hello. Yes. Can you hear me?
Yeah.
Okay.
I can please.
Okay. Yeah.
Hear you clearly.
Yeah. I just realized in the chat box that we have Shankar Stratka, Dr. Shankar Stratka, who is a classmate of mine during my years as well. So may I invite Dr. Shankar Stratka? You have any words to share here? Welcome, Dr. Shankar.
Yeah, thank you, Dr. Log. Sorry, I missed the first presentation, but I joined this second presentation. I think the presentation is very nice. I don't have much question, but one of my query is, I'm not sure in your river basin, you mentioned that your temporal resolution is daily data or monthly data, yeah? In case of Kathmandu basin, normally for the accurate representation, we even have to go beyond the daily, like sub-daily data or something like that. So is it necessary for your river basin? This is just my query. Is it necessary to do the same analysis on a sub-daily basis rather than the daily or monthly? Yeah, thank you.
Thank you, Dr. Shankar, for your comments. 𝐵𝐵𝐴NUJ,
Yeah.
are you clear with Dr. Shankar's query, right? Yes, yes.
Sorry, I think he asked
Okay, yeah.
Sanjeev.
No, not Sanjeev. Dr. Shankar. So one of our alumni just have a small query for you. So he shared. Maybe Dr. Shankar. Maybe you can repeat again the query for 𝐵𝐴NUJ. Thank you.
Yeah, it's for 𝐵𝐴NUJ, yeah, because
Yeah.
I missed the earlier presentation. So in your analysis, you mentioned that you are using the daily data and monthly data as a resolution, yeah.
Daily data I use for IHA model for study still for alterations.
So in your study, is that resolution enough, or you should also try for sub-daily data? I'm not sure. This is just my query, because in case of Kathmandu Bagmati River Basin, especially, we even have to go beyond the daily data, yeah, like hourly, 6 hourly data or something, sub-daily data for the analysis. Is it needed for your river basin? I'm not sure. It's just my question. Thank you.
Your questions mean the stream for alterations or the climate change analysis?
For the climate change analysis, yeah.
I think is if we use the daily data, you mean we have to use the daily data or not, right?
Yes, I mean the higher resolution data than you are currently using. Is it needed or not? I'm not sure.
No, I don't. I think it's monthly is enough.
It's enough, yeah.
For 10 analysis. If we use the daily, it's quite a high outline. It's high the highest outlier.
Outliers.
Yeah.
Thank you
so
very
it's
much.
difficult to define the 10.
Yeah.
Thank you very much. Yeah.
Thank you, Dr. Shankar. Yeah. Thank you, Dr. Shankar, for your questions. Please send my regards to your family as well. And I'm really looking forward to finally we can meet somewhere. Dr. Sangam, Professor Sangam already added some comments on top of your questions, Dr. Shankar. So actually, I also shared the view with Professor Sangam that either a sub-daily, even 15 minutes. In my case, when I was working in Singapore, they are using even 2 minutes. So sub-daily, daily, I mean, the temporal resolution is mostly decided by your objective. Are you interested to analyze the water resources, the water balance? So in that case, I think sub-daily, daily or weekly or monthly would be sufficient. But if you want to pick up the extreme events, let's say flood or drought, then maybe you will have to go into a sub-daily. So that's the very good point, Dr. Shankar. I just raised. So maybe you can justify that in your discussion that I'm interested in this objective. So that's why you think that monthly is sufficient. May I invite Mr. Tokyo Akta? I saw your chat. So please unmute yourself and ask 𝐵𝐴NUJ directly. Thank you.
My name is Tokyo Akta. I am PhD student from Pakistan.
Can you speak a little bit louder, Mr. Akta? Can you speak a little?
My name is Tokyo Akta. I am PhD student from Pakistan.
Sorry, I can't hear you clearly.
My voice is not clear.
Yes. Maybe if you may speak a little bit louder. Also, it's a bit small from our side.
Sir, my question is that what is the basic criteria to evaluate any historical hydrological alteration on any river? It was one of their objective. The objective was to evaluate the historical hydrological alteration on a Pacific River basin. Then what is the basic criteria to evaluate any historical hydrological data?
Okay, so Mr. Akta, I like to clarify first for 𝐵𝐴NUJ. So what your question is, what are the criteria to evaluate the hydrological alterations of any given river basin?
Yes, sir.
Am I understanding correctly?
Yes, sir.
Okay, thank you, Mr. Akta. So 𝐵𝐴NUJ, so you understand
The
the question,
criteria,
right?
yeah. The criteria for select the stations or the criteria, what kind of criteria that you mean?
Mr. Akhtar, so Kunpi Anuj want to clarify that you are interested to know the criteria that how she selected the station, or are you interested to know that how she did the evaluation to show the change of hydrological alteration?
Sir, basically there are two questions. First one is how she selected some respective stations. First one.
Okay.
Second one is that after selecting some prescribed station, how we can do further process or further evaluate the available data from that station.
Okay, so please correct me if I understand incorrectly. So Mr. Akhtar is interested to know that, okay, in the first part you have several stations. So how did you pick the stations to evaluate the hydrological alteration? That's one. And the second question is like after you selected these stations, what are the criteria that you chose to examine the
sir, along with that, if we have in Pakistan, if in any region, if we have missing data at any station, then how we can adjust or alter that data so that we have complete sequence, and sometimes the data of some year or some month is missing due to any reason. Third one, these three questions I want to ask.
Okay, thank you, Mr. Akhtar. I think one of your questions is about missing data. I think that will constitute a full course on how to handling missing time series data. I don't think we have enough time to answer in this particular limited time left. So for the question related to how to handle the missing data, you can write directly to Kunpi Anuj, and then she can share some of her experience on how we can handle the missing data. There are several ways to do that. You can do is a average or median, or how to fill data. So there are various techniques. So I think we won't have enough time to share. But I think for your two other questions, how she selected the stations and how she did the chose the parameters. I would say parameters to do the analysis. I think Kunpi Anuj can address. So could be please.
Yeah, I select based on these two. Actually, in this basin has many gauging stations, but only two stations that have a that's measure continuous time series. For this IHM model, is recommended we have to use the long-term data at least 30 years for this analysis to see the simple alterations. So that's why I select these two stations.
Yeah. Okay, and for the criteria, so after you chose the stations, how did you choose the parameters for to evaluate?
This the parameter that I chose is this. They are the all parameter that's available in this program. I didn't choose.
Okay. Yeah.
Because this is the spatial study, not a research. I just start, so I want to see all information about this river basin.
Yeah.
Yeah.
Yeah. Thank you, Kunpi Anuj. I hope that answer Mr. Akhtar's questions. So if you have any additional questions, please write directly to Kunpi Anuj, and then she can get back to you in more details. I think this is a very interesting, even though you say it is a special study, I think it's very interesting because it invites lots of questions. So I think Mr. Dugana over here have a very small question. So if you can try to address that in 1-2 minutes, I think that should be okay. So the question is like, since you have rightfully raised that the requirements for the data is 30 years of data continuously, so have you done any kind of homogeneity analysis of the data to check the overall trend first before you did the trend analysis?
Actually, I checked before show this, but in this presentation, I use the resource that didn't check homogeneity because I'm not sure that the change in above change is because of climate change or the observation? Yeah.
Okay. Yeah. So thank you, 𝐿 for a very informative Q&A questions. I think this is so far the very informative and best Q&A sessions in our WEM seminar series. Thank you everyone for raising the questions. So before we wrap up today's seminar series, I have a small announcement to make that as a tradition of this WEM seminar series, after 5 seminars, we will have a competition for the presenters, and for the last 5 we already have identified the winner. So we will be soon sending you the links so that you can recap all of the presenters and then vote for your best presenters. The best presenters will win a small prize as a token to be collected at our secretary over here, Yani. So with that, I would like to wrap up today's WEM seminar series number 10, and I would like to say thank you everyone for attending and questions. Please take care, everyone. Thank you.
Thank you.
Thank you. Goodbye, everyone. Have a nice day.
Thank you, Dr. Luke.